In this video, we will solve the questions asked in IIT JM Economics paper of 2025. The question is, suppose utility function of a consumer is, utility is a function of two goods x and y, which is equal to x times y, where x and y are quantities of commodities consumed. If price of x is $1 and price of y is $2 and income of the consumer is $100, we need to find out the utility maximizing quantity consumption of good x. Okay, so what we are being given here, we are being given the utility function, that is u is a function of, utility is a function of two goods x and y, which is related with the function x times y. Okay, price of good x is $1, price of good y is $2, that is being given. Also income of the consumer is $100. Okay, we need to find out the utility maximizing quantity. Okay, so that means our endeavor is to maximize the utility of the consumer, that is equal to x times y, subject to the budget constraint that he is facing. What is the budget constraint? That is price of x times units of good x plus price of y times units of good y should be equal to the income of the consumer. Price of x is 1, so we can write x here, plus price of good y is 2, so we can write 2 times y should be equal to the income of the consumer, which is given here 100. Okay, so consumer's endeavor is to maximize his utility subject to the budget constraint. Graphically it means, if I draw a simple graph here, we have units of good x on the horizontal axis, units of good y on the vertical axis. Okay, with the given budget constraint, let's draw here. This is the budget constraint. Consumer wants to achieve highest possible satisfaction. Okay, let us say this is IC1, this is IC2. So at optimality or utility maximizing condition, what happens? Consumer will reach to that very indifference curve where it is tangent to the budget line. Okay, so this is the point where they are tangent to each other. A tangency, we know that means first order condition for optimization in this case requires that the marginal rate of substitution between a good x and y should be equal to the ratio of the prices, price of x upon price of y. Okay, that means what's MRS? MRS is slope of IC, and px upon py is slope of budget line. Okay, so MRS is simply the marginal utility of x upon marginal utility of good y. It should be equal to the ratio of the prices. MUX is simply the change in the utility due to the change in the consumption of good x, and similarly MUY means the change in the utility due to the consumption of good y should be equal to the ratio of the prices. Okay, du upon dx means the partial derivative of utility function with respect to x, so derivative of x is 1, we are left with y, divided by du upon dy means derivative of the utility function with respect to y, so we are left with x. Price of x is 1 and price of good y is 2. Solving for this, so we get x is equal to 2y. Now what we do, we plug the value of x is equal to 2y into the budget constraint. Okay, so we have here, that is in place of x we have 2y, plus then we have 2y should be equal to the income, or 4y is equal to 100. Dividing both sides by 4, we get y is equal to 100 upon 4, which comes out to be 25. Okay, but we are supposed to find out the value of x, utility maximizing quantity of x. So plug y is equal to 25 in this equation. That means x will be equal to 2 times what we have done here, we got the value of x is equal to Okay, that is correct. X is equal to 2y means x is equal to 2 times the optimal value of y. If I write it here, it is 25. So x will be equal to 2 into 25, which is equal to 50. So 50 will be the optimal consumption of good eggs. Next question is, a monopolist produces a product and sells to two types of buyers, A and B. The inverse demand function for A and B are P is equal to 50 minus 5Q. P is the price, Q is the quantity of output, and P is equal to 100 minus 10Q. This is for the second buyer, which is B respectively. The monopolist's cost function is C is equal to 90 plus 20Q. The profit maximizing output of the monopolist for buyer B is, we need to find out. Okay, so we are being given the monopolist. We have two buyers. A, for A the demand function is, that is P is equal to 50 minus 5Q. For B the demand function is P is equal to 100 minus 10Q. Also cost function for the monopolist is 90 plus 20Q. Okay, we need to find out, if the monopolist wants to maximize profit, how much amount of output the monopolist should produce for buyer B. Okay, so we know that for profit maximization in case of what we call monopoly, we equate the marginal revenue for buyer B should be equal to the marginal cost. Okay, first we need to find out the total revenue for buyer B. So total revenue will be P into Q. So P is being given for buyer. We are being given P is 100 minus 10Q times to this we multiply by Q. Okay, so I am within the limits. So total revenue for buyer B will be equal to 100Q minus 10Q square. Marginal revenue for buyer B will be equal to the derivative of total revenue for buyer B upon the derivative of the output. So differentiating this with respect to, so we have to use the simple derivative, not partial here. So we differentiated with respect to Q. Derivative of Q is 1, so we are left with 100 minus derivative of Q square is 2Q, so 2 into 10 is 20Q. This is the marginal revenue for buyer B. Similarly, we need to find out the marginal cost. Marginal cost is the change in the total cost due to the change in the output. So we differentiate this cost function with respect to Q. So derivative of a constant is 0, derivative of Q is 1, so we are left with 20. Now equating marginal revenue with the marginal cost. Marginal revenue is 100 minus 20Q, and we equated the marginal cost, which we got is 20. Solving further, transpose this here and this there, so we get 100 minus 20 is equal to 20Q, which implies 80 is equal to 20Q, rather 20Q. So we got 20Q is equal to 80, dividing 20, dividing both sides by 20. Q will be equal to 2 1s are 2 4s are, so Q will be equal to Q will be equal to 4. Okay, next question is, suppose the GDP growth rate is 8% and the rate of savings in the economy is 40%. The incremental capital output ratio is, we are supposed to find out. Okay, so we are being told that growth rate of the GDP for the economy is 8% and savings rate is equal to 40%. Okay, we need to find out the incremental capital output ratio. Now what is incremental capital output ratio? It is simply the ratio of the investment and growth. That is, we know from Harrod-Domar model, Harrod Dormer model. One of the assumption is that savings is equal to investment. That means the incremental capital output ratio is simply the ratio of savings and growth. The formula is being given, that is growth rate is equal to savings rate upon incremental capital output ratio. Growth rate is 8%. Savings rate is being given as 40%. And we are being supposed to find the incremental capital output ratio. Multiplying this with this, so we get 8% times ICOR is equal to 40%, which gives us ICOR will be equal to, transpose this here, it gets divided, so we have 40% divided by 8%. Okay, so so it should be like this. Okay, now I am within the limits, so ICOR will be equal to 8 ones are 8 fives are, that means incremental capital output ratio for this economy is 5. Okay, it simply means ICOR means we need 5 units of money, or $5 or 5 units of currency to make one more unit of output for the economy. Next question is, suppose an economy produces 100 kg of rice in a year and sells that for $100 per kg. If the quantity of money in the economy is $500, then the velocity of money is, we need to find out. So by velocity of money, what we mean? By velocity of money, we mean, or rather we denote it by V. Velocity of money measures the number of times 1 unit of currency is used to purchase goods and services within the given period in an economy. That is, velocity of money measures the number of times one unit of currency is used to purchase goods and services within a given period. Okay, so let me rub this out. To find out the velocity of money, here we are being given, so we use the quantity theory of money to cut it short here. So according to the quantity theory of money, the relation is, that is money circulation or money supply times velocity of money is equal to price level times the GDP. Here GDP is output here, that is 100 kg. So money supply is being given as the quantity of money, that is the money supply is here 500 times V should be equal to, what is the price is rather 100 times the output produced is 100, which implies 500 V is equal to 1, 2, 3, 4, or V will be equal to, dividing both sides by 500, or we have divide by 500, you go yes with 10 into 10 is 5 into 20. So okay, so velocity of money is equal to 20 in this case. Okay, I hope it's clear to you. Next question is related to Nash equilibrium. The question is, the sum of payoffs to the players in the Nash equilibrium of the following simultaneous game is, we are being given the payoff matrix for two players. We have two players, player X and player Y, and their strategies are cooperate or not to cooperate. And similarly for player Y, we have cooperate or not to cooperate. Payoffs are being given in the cells. The first element in each cell denotes the payoff for player X, and the second element in each cell denotes the payoff for player Y. Or let me write it here with another color. So we have here 40, here we have 30, here we have 20. Okay, so the black number denotes the payoff for player X when she or he chooses a specific strategy, and similarly the red ones are the payoffs for player Y when she or he chooses a specific strategy. We need to find out the Nash equilibrium in this case, and we need to add the payoffs of the players. So let us first find out the Nash equilibrium. By Nash equilibrium, what we mean, Nash equilibrium is a situation in which a player chooses his best strategy given the other person or player has also chosen his or her best strategy. And where does this happen in this question? So how do we solve? Let me explain that very stuff here. So let us suppose player X cooperates. Okay, so when player X cooperates, player Y has two choices, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate gives him 30 as payoff. Obviously 50 is greater than 30, so let us underline this. Likewise, let us see when player X chooses to not to cooperate. Again, player Y has two options, either to cooperate or not to cooperate. Cooperate gives him 40 as payoff, not to cooperate gives him 20. Obviously 40 is greater than 20. Since we assume that the players are rational, they will choose higher payoff. Now let us see from the perspective of player X when player Y has chosen to cooperate. When player Y chooses to cooperate, again player X has two options, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate as 30. Obviously 50 is greater than 30, he will choose to cooperate. Symmetrically, when player Y chooses not to cooperate, again player X has two options, either to cooperate or not to cooperate. So cooperate gives him 40, which is greater than 20, so she or he will choose 40. Now where does the Nash equilibrium exist in this question? When both the numbers in a particular cell are underlined or encircled or whatever you call, that will give us the Nash equilibrium. Nash equilibrium cannot be Pareto optimal at times, okay, but it is the best strategy for both the players to cooperate in this simultaneous game. Now we need to find out the sum of the payoffs. So sum of the payoffs will be at Nash equilibrium, which is 50 plus 50, which is equal to 100 in this case. Next question is, the derivative of y is equal to x raised power e raised power x at x is, we need to find out, okay, the derivative. So we have y is equal to x raised power e raised power x. Okay, let us first take the log on both sides. Okay, that means log of y is equal to, now what is log of x raised power e raised power x? So e raised power x will become first coefficient times log of x. Okay, or let me write it with another color. We have log of x here. Okay, this is our okay. So now let us differentiate it. So the derivative of log of y is, we know it is 1 upon y dy upon dx. Now on the right hand side, we apply the product rule. That is, we write the first function e raised power x and take the derivative of second function, which is log of x, plus then we write the second function log of x and take the derivative of the first function, which is e raised power x. Okay, so let me use the proper color here. We have e raised power x, here we have also e raised power x. Okay, so we have 1 upon y dy upon dx. Okay, let me put it like this, is equal to, now we have e raised power x, derivative of log of x, we know it is 1 upon x, color combination की तेल लेने, plus log of x times the derivative of e raised power x is e raised power x, okay, times e raised power x, we know that very thing. Then dy upon dx will be equal to, transpose this y, it gets multiplied, so we have y times e raised power x divided by x plus log of x times e raised power x, or dy upon dx is equal to, y is this function, the given function x e raised power x, then we have e raised power x upon x plus log of x times e raised power x. Okay, but we need to find dy, the derivative dy upon dx when x is equal to 1. Plug the value x is equal to 1 here, so we have 1 raised power e raised power 1, then we have times e raised power 1 divided by 1 plus log of 1 times e raised power 1. So we have 1 raised power anything is 1. Okay, then we have e raised power 1 plus log of 1 is 0 times e raised power 1. So we get here, so 1 into something is something, so we have e raised e plus 0, which is equal to e, and the value of e is, I guess, 2.71. Okay, so the correct option should be 2.71 here.